A meniscus occurs because the adhesive forces between the water molecules and the glass walls are stronger than the cohesive forces between water molecules. The meniscus is located at the top of the liquid and is shaped as a U in the pipette being used to measure the volume. Reading the meniscus is found by looking at the bottom of the U and measuring the volume to the first estimated value. To record the volume using the pipette or graduated cylinder, subtract the initial recorded volume by the final recorded volume.
Stock solutions are accurate concentrations of a solution which can be used to create a dilution. A dilution is created when a substance such as water is added to a certain amount of the stock solution in order to decrease the concentration. The equation we use to determine the dilution solution is C1V1 equals C2V2. That is, original concentration multiplied by the original volume equals the diluted concentration multiplied by the volume of the diluted solution. This equation works because both solutions are proportional.
All members of the lab group are seen wearing proper clothing for the lab, which are closed-toe shoes, long pants, goggles, tied-up hair, and gloves. After checking for proper attire, members can be seen transferring the stock solution into a beaker for the next step of preparing the solution. Next, you can see each member grabbing a pipette and a bulb and carefully draws the solution to the pipette, making sure not to get the solution into the bulb. Next, you can see each member grabbing a pipette and a bulb and carefully draws the solution to the pipette, making sure not to get the solution into the bulb. The meniscus of the solution in the pipette is read by all group members before the solution is transferred. The solution is then transferred into a volumetric flask using pipette. The solution is then diluted in the volumetric flask using the transfer pipette. The meniscus of the volume flask can be seen sitting directly on the mark. Once the lab is complete, all members must participate in cleaning up the workspace. All materials and trash must be put in the correct area. Excess reagents are put down the drain.
Here in my notebook, I show how we made a 1% dilution from a 20% stock solution. I used the equation C1V1 equals C2V2 to find the volume of stock solution I needed to add to the 25 milliliter volumetric flask before diluting the solution. C1 is the concentration of the stock solution, 20%. C2 is the concentration of the dilution that we are aiming for, 1%. V1 is the amount of stock solution we need to add to the 25 milliliter volumetric flask. We don't know that yet. V2 is the amount we are going to dilute to. Since we are using a 25 milliliter volumetric flask, this is going to be 25 milliliters. After plugging it into the equation, we find that the V1 we need is 1.25 milliliters. So we got a pipette and drew up to an initial volume of 8.41 milliliters, and then released the solution into the 25 milliliter volumetric flask until it was 9.66 milliliters. Because the volume final minus the volume initial is the volume delivered, that means we delivered 1.25 milliliters of stock solution to the volumetric flask. This means that once we diluted that volumetric flask up to the graduation, we had 25 milliliters of 1% solution.